In this video, we're going to go ahead and do one full example of how to do these types of problems. So we have here the function f of x is equal to 3x minus 1 times x plus 2 times x minus 4 squared. Okay, the first thing that we want to do here is we're going to build our leading term. I'm going to try to color code everything here. Okay, so to build the leading term, what we need to do is we're going to look at every single term. So we're looking at each of these three terms, okay? And we're looking at the leading term in those terms. So in this case, the first term that we see here is 3x, and that is going to be the leading term in this parentheses because it's the one that has the highest degree. In this parentheses, it's x, and in this one, it is x as well. So our leading term is going to be 3x from the first parentheses times x from the second parentheses or the second factor times x again from this factor. But notice that this one has a degree of 2, meaning that there's actually 2 of these x minus 4s. So we have to put another one, okay? Just be careful with that. Like for this one, you have 2 of them because of this little 2 right here. So let's go ahead and multiply that out. It's going to be 3x times x times x times x. So that's going to be, see, 1, 2, 3, 4. Yeah, 4 x's. So it looks like 3x to the fourth power is our leading term. Okay, and again, this is how you build your leading term when you're given the factored form of a polynomial. So now that we have that, we can go ahead and figure out the degree. Okay, so it looks like the degree of this leading term is going to be 4. So that's our degree. And the number 4 is an even number. Let me use a different color here. It's kind of hard to see. So the number 4 is even. So here I'm going to go ahead and put even. Okay, our leading coefficient, well, that's the number in the front. So our leading coefficient is going to be this number here, 3. And we can see that 3 is greater than 0, therefore this one is going to be positive. Okay, so all these things combined are going to help us figure out the end behavior here. So let's go ahead and do that part next. Let's use this color. So the end behavior is whether the ends are going, up or down or, vice versa. And we get that by looking at our leading coefficient to see if it's negative or positive and the degree, okay? So in this case, it looks like our degree is even, it's 4. So that means that the graph should be going, either both up or both down. Since this is positive, it looks like it's going to be this one. They're both going to be facing upward. Okay, so I'm going to go ahead and erase the other one here. And if you don't remember this information, it is in your notes earlier. So just go back a few pages and you should be able to find those notes on and behavior here. Yeah, the patterns. All right, moving on. So the last thing we're going to do before we actually start graphing is listing the zeros and the multiplicities. So to do this part, we actually look at each factor. So our first factor is 3x minus 1. So 3x minus 1, and we're going to set that equal to 0. Okay, we can do one at a time, so we're not too cluttered here. If I'm solving for x here, well, I have to add 1 to both sides, okay, which will get rid of the 1's here, and I'm left with 3x is equal to 1. So therefore, you can see here after we divide by 3 that x is equal to 1/3, and this is going to be our zeros here. So one of our zeros is x is equal to 1/3. And in addition to that, okay, we're going to also find the degree of each of these zeros because the degree tells us whether or not the graph is going to cross or bounce off of the x-axis, okay? So it looks like the degree for this one, since we only had the one, we just had the one factor here, 3x minus 1. In other words, one parenthesis that has that is just going to be 1, which means that since it's 1, it's odd, which means this one is going to cross. Okay, let's find the next 0. So the next 0 we have is x plus 2. So x plus 2 is equal to 0. And this one's a little bit easier to see. We can kind of tell right away that if we're solving for x, we subtract both sides by 2, and that's going to give us x is equal to negative 2. Okay, x equals negative 2. And there's another one of our zeros. Okay, the degree for this one, well, there's only one parentheses that has this x plus 2, so there's only one factor. So the degree for this one is going to be also 1, which means that this one is also going to cross through the x-axis. Okay. The last one that we have here is this x minus 4. So that's going to be our last 0, x minus 4. We're going to set it equal to 0. Sorry, our last factor. And when we solve this one, if you add 4 to both sides, you can see that x is going to be equal to positive 4 for this one. Okay. Now this one, when we look at the degree, okay, it's also going to be, oh, actually, no, this one is going to be 2. So this one has something a little bit different. So the degree is 2 for this one, which means that since it's even, this one's actually going to bounce. Okay, now I want to go back just a little bit here and look at this word multiplicity. So this number that we actually found here is the multiplicity of that factor or that 0. So what that means is kind of like what I was saying, if you have more than one of those parentheses, like this one, for instance, we have 2 of them, okay? Well, the multiplicity would be equal to 2, which is the same as our degree in this case as this factor right here, okay? So just make sure you understand that. So now that we have all this information, we're going to go ahead and try to graph this. I'm going to start doing this by plotting the zeros first. Okay, so I'm going to plot these 3 zeros that we have here. We have x equals 1/3. So 1/3 I'm going to say is about right here, a little bit before 1/2. So this is 1/3. Okay, and then we have negative 2. So negative 2, let's put that one over here. Okay, and 4. So 4 is way over here. This is the first thing you want to do when you're trying to sketch one of these. Okay, the next thing we're going to do is we're going to go back to our end behavior here. So our end behavior was both of them are going to infinity. So let's go ahead and put those ends here. Remember, we don't really care too much about the exact shape, but we do want to know more or less where the graph is above, below, and all that kind of stuff. Okay, so those are our ends. And then what we're going to do next is going from left to right. So we're going to move this way. Okay, we're going to go ahead and do this part right here, the multiplicity part where we see whether the graph is crossing or bouncing at that part. Okay, so it looks like going from left to right, okay, at x equals negative 2, okay, the graph is crossing. So that means here I should be crossing. So there we go, we crossed. At x equals 1/3, so that's going to be this one, the graph is also going to cross. So following this so far, it looks like that one has to cross also. And the last one is going to be x equals 4. This one is going to bounce, which means that I'm going to go all the way this way, touch it, and then bounce back up. So this one kind of goes up something like that. So maybe if we wanted to maybe make that a little bit nicer, maybe the curve a little bit nicer, we could do that. Okay. So this one might look something like, oh, let me get my pen, something like this. Okay. Mine's a little bit crooked, but that's all right. So this is a pretty good idea of what this graph might look like, okay? And we just want to make sure that everything is where it should be. So negative 2 is crossing, check. 1/3 is also crossing, check. And at 4, it's bouncing. So it doesn't really go through the x-axis, it just touches it and then bounces right back up. So check. So we're good to go in that sense, okay? The last thing I'm going to do for this problem is identify where f of x is greater than 0. So we can say f of x, actually we'll do it this way. F of x is greater than 0, everything up here, but not including 0, okay? f of x is equal to 0, well, right on the x-axis, right? That's going to be these three black dots that I already have in black. And f of x is going to be less than 0 anywhere below. So down here, this is f of x is less than 0 because this is below. And remember, if you forget, you can always write. So this one's below, the other one is equal to, and this one is above the x-axis. Okay, so if I kind of color code accordingly, it looks like this piece right here is above. Okay, so this piece right here would be negative infinity all the way to -2 if we're thinking about the domain. Okay, this piece is also above. We're going to need this in just a bit. That's why I'm doing it right now. So this piece is also above, and that's between 1/3, so right here, 1/3, and 4, so comma 4. And actually, oh, and this piece also. Yeah, this piece is also above. So we got to be a little bit careful here because yes, we know that the 4 is also kind of sort of on the line, but 4 is equal to 0. So we're just talking about, greater than. So this would be 4 to infinity. Okay, so if you were being asked to solve an inequality, these might come in handy. Okay, the other piece that we don't have here is where it's below, and we can see that that happens right here in this little curve right here. So this piece right here is between -2 and 1/3. All right, with that in mind, let's go ahead and finish up our sign chart here. So the sign chart, this is a little bit extra, but that's all right. We're going to go ahead and just kind of line up our zeros. So we have a 0 at -2. We have one here at 1/3, somewhere right here. Okay, and then we have one here at 4. And all I'm going to do is label where the graph is above and where it's below. Okay, so just like what I did right now, I can see that on this side, it's in green, right? So from here to here, this whole part was above. So I'm going to put positive for above. So this whole piece was what I labeled as green, okay? From here to here, from -2 to 1/3, okay, that part was below. So I'm going to put a little negative here. It's kind of shaded in my color of below. For the next piece, it looks like we had also above, so this was positive, okay? And the last piece was also positive. Okay, so just some more information in case if you were solving a, you know, an inequality here. Let's kind of do an example just so you can see how this would go into play. So let's say we had, for example, you wanted to know where f of x was greater than or equal to 0, for instance, okay? So anywhere that this happens is when the graph is above, okay, and equal to 0. So above is going to be pretty much anywhere we have the green. So it's going to be this guy here, this guy here, and then, and actually this one's going to be a little bit easier because since it's equal to 0 also, we can just put this whole thing together. So let me give an answer for this one. For this one, we would have negative infinity to -2, because that's the first piece right here, okay? And also this piece over here. So that's going to be from 1/3, and actually we should probably put brackets here, right? Yeah, we want to put brackets here because it's equal to. So if it's equal to, we can go ahead and include the zeros here. So 1/3 all the way to, well, it's going to be to infinity in this case, because even though we have this 0 here at 4, it's equal to 0 in this problem. So we're allowed to do that. And that would basically be it for that one. Okay. So I believe that is it for this video. Thank you very much.